ASTM C231 is the standard test method for air content of freshly mixed concrete by the pressure method. This test method covers the determination of the air content of freshly mixed concrete from observation of the change in volume of concrete with a change in pressure. This test method covers the determination of the air content of freshly mixed concrete. The test determines the air content of freshly mixed concrete exclusive of any air that may exist in voids within aggregate particles. For this reason, it is applicable to concrete made with relatively dense aggregate particles and requires the determination of the aggregate correction factor. This presentation does not suggest to address the safety concerns associated with this procedure. It is the responsibility of the viewer of this presentation to follow all safety procedures, rules, and standards established by private companies, government agencies, and construction site supervisors. This presentation uses both inch-pound units as well as SI units. These units shall be regarded as separate. In other words, the value of one unit shall not be considered the exact equivalent of the other. Therefore, the units shall not be considered interchangeable. Any conflating of the two systems may result in non-compliance of this standard. This test method and test method C138 and C173 provide pressure, gravimetric, and volumetric procedures, respectively, for determining the air content of freshly mixed concrete. The pressure procedure of this test method gives substantially the same air content as the other two test methods for concretes made with dense aggregates. There are two types of meters employing the principle of Boyle's law. For purposes of reference herein, these are designated meter type A and meter type B. The type A meter is an air meter consisting of a measuring bowl and cover assembly. The operational principle of this meter consists of introducing water to a predetermined height above a sample of concrete of known volume, and the application of a predetermined air pressure over the water. The determination consists of the reduction in volume of the air in the concrete sample by observing the amount the water level is lowered under the applied pressure, the latter amount being calibrated in terms of percent of air in the concrete sample. Type B meters also consist of a measuring bowl and cover assembly. The operational principle of this meter consists of equalizing a known volume of air at a known pressure in a sealed air chamber with the unknown volume of air, that is, the air in the concrete sample, being viewed on the dial gauge. The pressure gauge is being calibrated in terms of percent air for the observed pressure at which equalization takes place. Working pressures of 7.5 to 30.0 psi, or 50 to 205 kilopascals, have been used satisfactorily. Whether it be a Type A meter or Type B meter, the bowl shall be made of steel, hard metal, or other hard material not readily attacked by the cement paste, having a capacity of at least 0.20 cubic feet, or 6.0 liters. And a minimum diameter equal to 0.75 to 1.25 times the height. The measuring bowl and cover assembly shall be sufficiently rigid to limit the expansion factor of the apparatus assembly to not more than 0.1% of air content on the indicator scale when under normal operating pressure. The cover assembly shall be fitted with air valves, air bleeder valves, and petcocks for bleeding off, or through which water may be introduced as necessary for the particular meter design. A suitable hand pump shall be provided with the cover either as an attachment or as an accessory. There must also be a gauge readable to 0.1% as determined by the proper air pressure calibration test. The rod shall be a round, smooth, straight steel rod with a 5/8 inch or 16 millimeter diameter. The length of the tamping rod shall be at least 4 inches, or 100 millimeters, greater than the depth of the measure in which rodding is being performed, but not greater than 24 inches, or 600 millimeters in overall length. The rod shall have the tamping end, or both ends, rounded to a hemispherical tip of the same diameter. When using a vibrator, the vibrator frequency shall be at least 9,000 vibrations per minute, or 150 Hz, while the vibrator is operating in the concrete. The outside diameter, or the side dimension of the vibrating element, shall be at least 0.75 inches, or 19 millimeters, and not greater than 1.5 inches, or 38 millimeters. The combined length of the vibrator shaft and the vibrating element shall exceed the depth of the section being vibrated by at least 3 inches, or 75 millimeters. The frequency of the vibrator shall be checked in accordance with the manufacturer's recommendations, or at least every 2 years with a tachometer or other suitable device. A mallet is also necessary. The mallet, with a rubber or rawhide head, shall have a mass of 1.25 pounds, plus or minus 1/2 pound, or 600 grams, plus or minus 250 grams. For use with measures of 0.5 cubic feet, or 14 liters or smaller. And a mallet having a mass of 2.25 pounds, plus or minus 1/2 pound, or 1,000 grams, plus or minus 250 grams, for use with measures larger than 0.5 cubic feet, or 14 liters. A flat, straight bar of steel or other suitable metal at least 1/8 of an inch, or 3 millimeters thick, 3/4 inches, or 20 millimeters wide, and 12 inches, or 300 millimeters in length. We can also use a strike-off plate. A flat rectangular metal plate at least 1/4 inch thick, or 6 millimeters, or a glass or acrylic plate at least 1/2 inch thick, or 12 millimeters, with a length and width at least 2 inches, or 50 millimeters greater than the diameter of the measure with which it is to be used. The edges of the plate shall be straight and smooth within a tolerance of 1/16 of an inch, or 2 millimeters. We'll also need a measure for water, having the necessary capacity to fill the indicator with water from the top of the concrete to the 0 mark. A field favorite is the 6x12 plastic cylinder mold. Depending upon the aggregate size in the concrete, we may need a 1/2 inch or 37.5 millimeter sieve with not less than 2 square feet, that is 0.2 square meters, of sieving area. We're also going to need something to add water to the meter. Using a bulb syringe or plastic wash bottle has been found to be satisfactory. And, of course, we'll need a scoop. This test method is intended for use with concrete made with relatively dense aggregates, for which the aggregate correction factor can be satisfactorily determined. This test method is not applicable to concretes made with lightweight aggregates, air-cooled blast furnace slag, or aggregates of high porosity. In these cases, test method C173 should be used. This test method is also not applicable to non-plastic concrete, such as is commonly used in the manufacture of pipe and concrete masonry units. If the aggregate is larger than 2 inches, or 50 millimeters, the sample must be wet sieved over a 1 1/2 inch, or 37.5 millimeter sieve. We will also need to know the aggregate correction factor. This procedure should be completed in accordance with Section 6 of ASTM C231. The procedure should be completed on a combined sample of fine and coarse aggregate in similar amount, condition, and proportions as those in the concrete under test. The aggregate correction factor does vary with different types of aggregates. Since it is widely believed that the aggregate correction factor is not directly related to absorption, it can only be determined by the test described in ASTM C231. Base the method of selection of the method of consolidation on the slump. If the slump of the concrete is greater than 3 inches, or 75 millimeters, the concrete must be rodded. When rodding, the measure must be filled in 3 equal layers and rodded 25 times uniformly across the cross-section of concrete with the rounded end of the rod. If the slump of the concrete is less than 1 inch, or 25 millimeters, the concrete sample must be vibrated. When vibration is the consolidation method, the measure must be filled into equal layers. The vibrator must be inserted at 3 locations across the surface area of the concrete. Be sure that all the concrete, for each layer, has been placed in the measure before the vibration begins. Under normal circumstances, one can assume that sufficient vibration has been achieved when the surface of the concrete is relatively smooth with a glazed appearance. Be sure not to over-vibrate the concrete, as this may cause segregation and loss of entrained air. Never vibrate so long as to cause escape of froth from the sample. If the slump of the concrete is between 1 inch and 3 inches, or 25 to 75 millimeters, either consolidation method is acceptable. Now that we understand the basics of ASTM C231, let's go through a detailed performance review. In this example, we will be using the Type B air meter. And since the slump of our concrete is greater than 3 inches, or 75 millimeters, we will be using the rodding method. Obtain a sample in accordance with ASTM C172. Dampen the interior of the bowl and remove any standing water from the bottom of the bowl. Place the bowl on a flat, level, firm surface and add the first layer of concrete. Move the scoop around the perimeter of the bowl opening to ensure an even distribution of the concrete with minimal segregation. We can now rod the first layer 25 times. As always, we'll use the rounded end of the tamping rod. We'll rod the first layer throughout its depth, without forcibly striking the bottom of the bowl. Now, tap the sides of the bowl 10 to 15 times with a mallet, using such force as to close any voids left by the tamping rod and to release any large air bubbles that may have been trapped. We can now add the second layer of concrete, again moving the scoop around the perimeter of the bowl to ensure even distribution and minimize segregation. The second layer should fill the bowl to approximately 2/3 its volume. We now want to rod the second layer 25 times. The second layer is rodded throughout its depth, penetrating the previous layer by approximately 1 inch, or 25 millimeters. Once again, tap the sides of the bowl 10 to 15 times with a mallet, using such force as to close any voids left by the tamping rod and to release any large air bubbles that may have been trapped. Add the third and final layer of concrete, taking care not to overfill the bowl. Rod this layer 25 times throughout its depth, penetrating the previous layer by approximately 1 inch, or 25 millimeters. Tap the sides of the measure 10 to 15 times with a mallet. After tapping the third layer, but before striking off, a small quantity of representative concrete can be added or removed to compensate for slight deficiencies or excesses. 1/8 of an inch, or 3 millimeters above the rim of the measure, is considered optimum. However, if the excess amount of concrete is greater than 3/4 of an inch, the procedure must be discarded and start anew. After consolidation of the concrete, when using a strike-off bar, strike off the top surface by sliding the strike-off bar across the top flange or rim of the measuring bowl with a sawing motion until the bowl is just level full. In our example here, we will be using a strike-off plate. When a strike-off plate is used, strike off concrete as prescribed in test method C231. Press the plate on the top surface of the concrete, covering approximately 2/3 of the bowl. Then, in a sawing motion, withdraw the plate to finish only the area that's been covered. Now, put the plate back on top of the bowl, covering only the original 2/3 of the surface. Then, with vertical pressure in a sawing motion, advance the plate off the bowl. Incline the plate and perform final strokes with the edge of the plate to produce a smooth surface. After strike-off, thoroughly clean the flanges or rims of the measuring bowl and the cover assembly so that when the cover is clamped in place, a pressure-tight seal will be obtained. Assemble the apparatus. Close the main air valve between the air chamber and the measuring bowl, and open both petcocks. Add water through one petcock until water emerges from the opposite petcock. Jar the meter gently until all air is expelled from this same petcock. Close the air bleeder valve on the air chamber and pump air into the air chamber until the gauge hand is on the initial pressure line. Allow a few seconds for the compressed air to cool to normal temperature. Stabilize the gauge hand at the initial pressure line by pumping or bleeding off air as necessary, tapping the gauge lightly by hand. Close both petcocks. Open the main air valve between the air chamber and the measuring bowl. Tap the sides of the measuring bowl smartly with the mallet. Lightly tap the pressure gauge by hand to stabilize the gauge hand. Read the percentage of air on the dial of the pressure gauge. If the air content is 8% or less, record the air to the nearest 0.1%. However, if the air content is greater than 8%, record to the nearest 0.5%. Release the main air valve. Failure to close the main air valve before releasing the pressure from either the container or the air chamber will result in water being drawn into the air chamber, thus introducing error in subsequent measurements. In the event water enters the air chamber, it must be bled from the air chamber through the air bleeder valve, followed by several strokes of the pump to blow out the last traces of water. Release the pressure by opening both petcocks before removing the cover. We now want to report the air content to the nearest 0.1% after subtracting the aggregate correction factor. When calculating the final air content in the percent of the sample tested, the equation is A subscript S equals A subscript 1 minus G, where A subscript S is the air content of the sample tested in percent. A subscript 1 is the apparent air content of the sample tested in percent. In other words, the air content read on the dial gauge. And G is the aggregate correction factor. So let's assume the A subscript 1, or the reading on the dial gauge, was 6.5%. The G aggregate correction factor is 0.4%. Then the air content of the sample tested in percent, or the A subscript S, is 6.1%. And this concludes ASTM C231, standard test method for air content of freshly mixed concrete by the pressure method.
Ready to jump?
Yeah.
Oh, shit. How's
How's them petcocks doing?
Rats.